productionizing NLP models. NLP models. Raviraja likes to follow the latest research happening in the NLP domain. And besides work, Ravi likes cooking all kinds of Indian food. He's a fan of chutney, especially the mango kind. Yeah, he can be found cycling on an electric bicycle and enjoying kdramas. That's Raviraj, who's joining us today to talk about end-to-end machine learning. Welcome to the MLOps community meetup. Raviraj, thank you for joining us today.
That was a cool intro and I haven't heard. Thanks for that.
I added in a little bit of flavor. Raviraj did not tell me he likes electric bicycles, but I put it in there because I figure you're environmentally conscious and stuff like that. So there we go, man. I'm going to hand it off to you now. It is your time to shine and tell us all about what you've got going on. For everyone that is in here, and if you want to ask any questions along the way, you can feel free to put it into the chat or put it on the Q&A, and I'll stop Ravi at the opportune moment so that we can ask him these different questions. And that's all I got, man. I'll let you share your screen as you're doing that. Again, feel free to join in the MLOps community Slack if you're not in there already. I'm leaving a link in the chat. And now, Ravi, it looks like it is all you, man. I see your screen and we're good.
Let me start sharing a screen. Is the presentation visible?
Yep.
Yeah, cool. The topic for the day is getting to know the basics of end-to-end MLOps. Let's get on with it. So a little bit about me, apart from what Demetrius have already shared, is that I'm currently working at Enterpret as a founding engineer, and I'm working majorly on extracting customer insights for product builders and all. Prior, I have worked on building and patenting the domain-specific document comprehension module. I also write time-to-time blogs on NLP and MLOps-related things. The agenda for the day is like why MLOps, or what is the need of MLOps and all, and what MLOps lifecycle looks like. And let's go to deep dive of each component in that, and what could be the next steps on any Q&As in there. Looks good. Let's get started. Why MLOps? So there's a Google survey on this that 72% of organizations that began AI integrations and all before 2019 are not able to deploy even a single application in production. And one more survey by Algorithma Service states that 1 in 2 companies, they are not able to deploy the models in production. And a couple of surveys, the other survey by ML practitioners at Full Stack Deep Learning shows that what is that least challenging to what is the most challenging component in that. Fortunately, or like because of high resources and all whatnot, the model training seems to be the least challenging part, whereas coming to the model deployment, model monitoring, and model maintenance and retraining, that seems to be the hardest part. There will be, there are data related things also, but as you can see, majority of the things people are facing is related to deployment and monitoring and maintenance part. So in a nutshell, that successful deployments, adapting to changes, effective error handlings are the bottlenecks for getting value from AI. Now, what is MLOps, or how does this solve the problems? The goal of MLOps is to reduce the technical friction to get the model from an idea to production in the shortest possible time to the market with as little as risk as possible. So this covers like automations or what is the monitoring stuff required, how you scale the things, whatnot. So it covers each and everything, tries to cover each and everything, coming to keeping the model in production, keeping it running. Now, yeah, what does a typical MLOps lifecycle looks like? So this is from Google source on practitioner guide to MLOps, but people tend to follow different kind of architectures and all. So it's just a rewording of things into different buckets and all. But high level, these are the 7 steps included or involved in the MLOps lifecycle. So let's go through each of them and get a gist of what that each step involves. ML development. Yeah, so this concerns with developing and experimenting a robust and reproducible training model, training the pipeline code and all, data engineering, featuring development, everything here, which consists of multiple tasks like data preparation, transformation, model training, and evaluation of it. So this is just that you have a problem statement and you want to develop a model out of that. Now, in order to make the process more robust and all, so you have to have that automating the process with all the packages involved, and how are you testing the model and how are you deploying that model so that you can have repeatable and reliable and reproducible training pipelines. So the training optimization concerns about that. Continuous training here, it's not necessary that you train a model once and be done with that. So you might have incoming data changes are there, or you might want to try different hyperparameters at a time. Different things can happen. So not every time you want to go back and set up the code again and again and start that. So there should be a streamlining process that change this, and there should be a trigger, or there should be automation done that, so that you can automatically trigger the training process. Yeah. Once the model is trained, so in order to get value from that, so it needs to be deployed somewhere, whether it is in production or somewhere, so that people can try to use that. So this step concerns with packaging, testing, and deploying to a serving environment for any experimentation or actual serving and all. Prediction serving, there is a minute difference between model deployment and serving. So serving can be treated as an architecture where you might have thousands or hundreds of model you want to serve, and there could be different kinds of environment and all. So prediction serving, since it contains more about infrastructure related issues and all, that was maintained as a separate step. That, yeah, once you have a model available in that environment or at a location, how do you actually serve it, and how do you scale it and all? So all that issues will be dealt at the prediction serving level. Continuous monitoring. Yeah, so once the model is served, you are using it in production and all, but how it is performing is, are your predictions are making accurate things or not? Is everything going smooth according to what you expected or not? So all these things were handled by the monitoring cycles and all. The final step is the data and model management. So as we all know that machine learning involves or deals with more amount of data, and you will be training models and all. Compared to typical code architecture, which are normal code files and all, the sizes of data and models are very high. It could be vary from few KBs to few TBs also. And managing all this and making sure that it is reusable or reproducible, all these things is a challenging task, and that's why it's data and model management is also a part of MLOps lifecycle. Now that these are the high level 7 steps involved in the MLOps cycle, let's see a deep dive into it, or what tools can be used to solve each of these steps. A bit of disclaimer that there are different ways people are trying to use it, or there are many tools coming up nowadays, each excelling at a one part. So the ones I'm showing, about to present, are my personal choices, depends on how we are using it at my company. And my personal preference, it's not a cohort or the comprehensive presentation. There are many tools out there, but the intention is to get started with some tool, or get an end-to-end understanding of how things work, and then go dive deep into and see what tools can be used even better. Coming to the first step, which is developing a model. Once the problem is defined, once the use case is defined, or once the business use case is done, that this is the data, once the data is defined and all, you can develop a model using any of the library available out there. It could be Pytorch, TensorFlow, Scikit-learn, or anything. what I have used for my exploration purpose is the Pytorch Lightning. Why? I'll try to give a justification of why I try to use it. Not like that other platforms are not bad or so. I prefer this. Why? Because it makes coding the complex networks very simple, because they have engineered a lot of the typical thing like converting tensors to CUDA format or shifting that, or they make a specific things like training step, evaluation step, validation step, and also you don't have to worry about where the training is happening. You can directly go to the module and there is a training step always defined. So it makes the coding practices very easy and all. So you don't have to worry about are we following the practices correctly or not. You need to spend more time on your research rather than you organizing the code where to go and all. And you don't have to worry about precisions or there are many optimizations nowadays coming up, scaling up, multi GPUs and all these things were done for you. So you just have to worry about what is the model you want to build. All the other part is done by Pytorch Lightning. So that's why I really personally like it, so that I personally don't want to manage all that multi GPU or precision things or whatnot. So they have done all that, and there is a active community going on about like what are the pre-trained models and how to use it in an easy way and all. Yeah. So once the model is trained, like it's not necessary that you have only one parameter. You might have to pick multiple parameters or want to try different model strings or different architectures you want to try for a given problem, or different metrics you want to evaluate on the model on. So all these things are there, and there should be a single place. It would be easy to have all these metrics or outputs at a single place so that you can compare. Okay, these are the comparisons across different runs and all, and this is my best model. This is my best configurations. I can use that for the final training of model. So model monitoring makes the development cycle. You can understand the pitfalls of whether it is at a data level or at a model level, whatnot. So for that modeling purpose, I personally prefer weights and bias. There are many tools out there, so for each of the step involved. But as I said, these are my personal choices. Weights and bias, you can see how a gist of a dashboard gonna look like if you try running different things. And you can see that here best model val accuracy is this thing, and you know that it is what run it is. And if you go inside that, you can see what are the actual parameters used in that for that particular run. And it has many more advanced features, like you can commit the code. Actually, you can try different codes for each of the runs and all, and you can commit the code, and you can see actually in the weights and bias dashboard itself that what is the code used for this particular run, or what are the artifacts generated or used for this particular run. Yeah, so monitoring is useful. Now, configuration management. If I'm going too fast, let me know so that I can go a bit slow, talk more about that. If not, I will be going at this pace. Configuration management, why it is necessary? I think majority of no one majorly talks about that specifically, since it's not related to machine learning, it's related to software engineering and all. But configuration management is necessary because you want you are trying to build a complex systems, or you want to have swappable elements between these things, or you want to have a reusable things. Let's say typical configuration files of YAML file looks thousands of lines and all, which is not very easy to manage and all. So how what tools can be used, or how things can be built so that we can easily swap the elements between the configurations across different systems and all, or different environments and all. So this can get very, very ugly if not managed properly. So for that, I personally prefer a Hydra, so which does an amazing job of you have a powerful, you can compose configurations dynamically, that you can split the configurations into n number of files, and you can compose at a single place, and you can infer that, or you can interpret different variables and all. So for every step I am mentioning, there is a detailed blog post I have written for that on technical details and actual code work there also. So I'll provide the links anyway at the end for each of that. Okay. Any questions up until now? I think I want. Demetrius, any?
Nothing yet.
Cool. Yeah. Nice. Yeah. Now coming to the data and model management, that as I said, that classical code version systems, whether it is a GitHub or Bitbucket and all, so they are not designed to handle very large files, which makes the cloning or storing the history impractical, and which are very common in the case of machine learning for the data and models. It as easy as 100 MB, as simple as 100 MB. So in order to do that, so how data and model management can be done is via a tool called DVC, which is data version controlling. So it doesn't like it is as similar to Git, just that you are able to store your corresponding code and models at a different location at your remote server, which you can configure through any of that cloud services provided, which is S3, GCP, or your local VM, or any custom thing. They have a support of more than 10 open source storage systems available out there. So here they'll keep a snapshot of that, like they'll hash it and they'll store it, like how .git is created. There is a .dvc file created for everything you commit, and it will be tracked at Git. So the actual data is stored at a different location, and the snapshot or the hash version of it is stored at a Git thing. So that's how they are going to manage the data and model management, which makes the job of everyone easier. Now you have a model, like you might be, it's not necessary that you might prefer a particular framework for building it because it's very used, or you have a personal preference, or the company is using that. But it's not necessary that you might be using that model at a same infrastructure level or at a same library level. So you might want to train a model in Pytorch because that's easy for you, but you might want to deploy the model in a C++ environment or a TensorFlow environment because that is fast for inference comparatively. Or you might want to deploy the model at a edge systems or a mobile systems or a browser thing, which doesn't have that much. The models you train might have a single format, which is a Pytorch is a PT format, TensorFlow has a TF format, and scikit-learn has a pickle format and all. So, but having a single format will help us like decoupling the systems of, you don't have to worry about which framework you're using for training and which framework you're using for deployment and all. So having a single common file format will help us a lot. And that is achieved by ONNX, which is from Microsoft. So where you can train your model using any of the framework you like to do, and you export that model to a common file format. And that can be leveraged, or that can be run across. Currently, it is, I think, most of all the top level organizations and top level libraries are supporting the inference formats or the model formats of ONNX. There are a couple of issues, but people are still solving all those things. But yeah, it's a good to have that, having a single file format so that you don't have to worry about where things to run and all. Now coming to the model packaging. So one thing is we might have to package our code. So you might be building in your own local system and all, but you might want to test it or train it in order to scale it in a different environment. Common issue is it works on my system, but not on others. So that's a common thing we usually hear, whether it is a dependency issue or a OS related issue or whatnot. In order to solve all this, I think everyone aware the Docker is there. Where you define a Docker file containing all the dependencies and how to run or what to run, or what are the environments you want to use, or what are the things you want to expose and all whatnot. And then you build a Docker image, which will then package all that code, all the dependencies into a single image. And you can store that in a central repository somewhere in Docker or whatnot, container repository. Then you spawn that image and run in your corresponding environment. So so that's the code packaging part. Now coming to the continuous integration, continuous delivery, that in order to make the cycle faster, like in order to make the deployments faster, or whatever the iterative code changes you build and all, to see whether it is working or not. So all these things needs to be in a more continuous way, so that you can try more experiments. You don't have the overhead of transferring that, okay, now the model is trained in the system, now I have to deploy there and all. So all these things can be automated via CI/CD. There are many tools which are supporting nowadays. Everyone knows all this stuff, but anyway. So I'm using GitHub Actions particularly because, there are very good tools out there, but I prefer GitHub Actions because I don't have to worry about a platform switch between a CI/CD tool I'm using GitHub for my code maintenance, and also GitHub Actions is right away there itself, all the security concerns or whatnot. And it's easy like for integration and all. Don't have to learn too many tools also there. So all the standard formats works there also. Yeah. Now we have built a Docker image. Now it has to be stored somewhere so that we can access it, or not only we, any people in the organization can access it, so that they don't have to repeat the same experiments again. So we say that, okay, we have the model trained in this Docker image, so use that image directly. So that allows us to collaborate more on that. They helps us to improve on the existing code base and whatnot. So in order to do that, we have to have a common repository, like how the code is maintained at Git. So the images should also be maintained at a certain level. And there are many container registers outside available. I'm using ECR, Amazon ECR, Elastic Container Registry. What it offers some security concerns, like it will compress and encrypt and all also, which might not be a major concern right now. But yeah, so once you can write your Docker image and store that in the ECR, it can run in any of that compute available there, whether it is ECS, EKS, or serverless, it is Lambda and all whatnot. It can run anywhere, and you can pull it from anywhere also. So like how till now, what's happening is that, so there is a data scientist, and you develop your code and you port that to a ONNX file format so that you have a single thing you can run anywhere, and you maintain all this via Git thing. Then you process the model to a remote location. It could be anything. Since I'm using an AWS stack, I am using AWS S3 to store the remote model, the train model and all as a remote storage as S3. Then I am configuring a GitHub action that whenever something triggers, whenever some code changes triggers and all, do this training and store the model here, and then fetch the model from here and build a Docker image out of it, and then store that image in the ECR. Now, how this deployed image or the created image can be used to create a container and use the compute, that's what we'll be going through. That is the model deployment. So what is a typical model deployment gonna look like is you have to set up your and maintain the servers in EC2 instances in which the models are deployed. So you have to configure all that. This is the RAM, or this is the GPU, or this is the memory, and this is the compute I'm using, and all the package dependencies and all. You have to install that and set up that. And there could be managed scaling that you might not receive only single request at a time. You might have thousands of requests at a particular point of time and only no requests at a particular point of time. So you have to manage the scaling part of the deployed model also, and manage time to deploy models, like all these things, like you build a model here, how to set up that, all this infrastructure, and then transfer the model here and all whatnot. So how can a single, like it gets, I mean, it's not the only way to deploy it. There are many ways that people are trying to use, but this is easier, the general way people try to use. But how can a single developer like maintain all these, like configure all this stuff, and worry about scaling and all these things? So this is where I think I personally prefer a serverless architecture thing. So what does that serverless means architecture? It means is that serverless architecture is a way to build and run applications and services without having to manage infrastructure. The application still runs on servers, but all the server management is done by a third-party service. It could be AWS or Google Cloud, whatnot. We no longer have to provision, scale, and maintain servers to run the applications, databases, and storage systems. It depends on the request. It will auto-scale. Depends on how much scalability you have. Those all depends on plans and all. But yeah, by using a serverless architecture, developers can focus on their core product instead of worrying about managing and operating servers and runtimes, either in cloud or on-premises. This reduces the overhead, let the developers reclaim time and energy that can be spent on developing great products. So this is one pro, I would say. It's not necessary. Everything is a pro regarding serverless. There are many cons also of it. Like if something breaks, if it's a typical EC2 system, I can log into the system and I can try to debug on it. But if it is a serverless, there is no proper way to debug into the machine. But all the things which are necessary for debugging, you have to make sure that you are logging the necessary things there. But major, if you see the pros of it, that which is you don't have to manage all these like scaling of the systems, or spawning up that or maintaining all these, spinning up the systems, and also it will be done automatically for you. So which is a trade-off. There's always a trade-off for every kind of architecture you choose. Depending on the pros, I thought serverless would be preferred more often. So coming to the prior architecture, so we have triggered a build which stores the Docker image at a particular Elastic Container Registry. Now you can have a different trigger for that which fetches the image from that Elastic Container Registry, and AWS Lambda is the serverless functionality provided by AWS. So I think in Google it is a step functions and all. Yeah, depends on the service provider, the name changes, but it's usually the serverless, which fetches the image from the ECR, and AWS Lambda can be configured with a Docker image automatically. So it updates that Lambda with that particular image, and you can have different APIs mentioned that if this is the API hit, then you execute this part of the code in that your code base. So that's how it can be configured. Yeah, let me stop at this point. Any questions up until now?
So I had a bit of a question about how you see some of these tools. Like, do you feel like some tools do the same things, but you have to decide one tool or the other for how you're going to use it?
Yes, good question on that. So one sample example is DVC versus weights and bash. Weights and bash also store the models now. They also provide the functionality to store the artifacts at their storage and all. Then DVC is also doing the same thing. Like DVC, with DVC you can also use monitoring or whatnot. All the dashboard I have shown for the weights and bash thing, right? That thing can be done at DVC level also. Then the decision point comes, right? Should I use DVC for all these things? Should I use weights and bash for all these things? Or should I use DVC only for storing and weights and bash only for monitoring? It's like a decision point one needs to make. If you don't want to worry about too many tools and all, I think going with the one tool which provides majority of the functionality will help us getting things faster. You don't have to have different learning curves for each of the things would be there. So don't have to worry about that. But depends on ease of use also, like what organization is already been using and how can we build on top of that. So it's already, if S3 is what people are using to store all the data and models, but weights and bash might or might not support with the S3 thing, I have to go back and check on that. But let's assume it is not. Then you coming up with a solution that, okay, I will store all the data and models now at weights and bash, not at S3, would not be a very good way to do it. So depends on a decision. I would say that personal choice and also or organizational choice, whether which tool to use properly. But the thing is, you have to achieve that functionality to store the things at a remote location, to track the things, able to track it, able to reproduce it, or able to identify what all the parameters used to build that model. So whatever the tool you use, it's a choice, but the thing you have to achieve is reproducibility at the end goal.
Yeah, that makes total sense. And I like how you talk about, it's like in the beginning, just use one because that's the easiest. And then once you feel more confident with that one, you can bring in another one and let your maturity grow. And along those lines, like, because I know DVC also has their sister tool, CML. Have you looked into that at all and how that plays with GitHub Actions and where this would even sit in?
Good question. Yeah, continuous machine learning, the CML tool, is a part of GitHub Action actually, where you want to test you change a hyperparameter now, and you don't want to train it. You might have to train it also. Let's assume that you are training it because of the continuous training pipeline trigger. You train it, you change the code parameter, you train it, and your new model is trained. Now, how do you know that whether this is this performs better than that? Is ideally you have a common test data that you perform the evaluation on top of it, and have a metric around whether it is F1 or accuracy. Let's assume it's an F1 metric, and you compute that metric on the common test data and see, okay, with this configuration, this is what you are getting. Ideally, this can be logged at training level, which is at either at a DVC or a weights and bash level. but it would be, if I raise a PR on top of it and all, people don't know how this is impacting. They have to go back to that different dashboard, which is a weights and bias, and check, okay, this is the configuration used or this is the run used, and what is the metric or what is that evaluation metric I'm getting for this particular change. What CML does is that it's a part of a GitHub action, and you can beautifully write the table or comparison or the confusion metrics or I think it is supporting most all the metrics, the commonly used metrics, and you can log all that at the PR level itself. Whenever you raise a PR, it will automatically trigger that particular evaluation thing and all. It will automatically compute that, and it will beautifully make a table out of it that this is the existing thing, and you can compare things also there with the particular branch and code and whatnot, and it will automatically have that comparison table right in the PR itself. So you don't have to go to a different location and compare things. Everything is at a single place. That's how the CML can be used as a part of GitHub.
I see. Is there a reason why you chose against using it?
No, it's not. I'm not against it. I haven't. I explored it, but I thought, I will cover it at a later point of time. Let's not. If I delve too much into each part, it might take too much time to cover each and every aspect. That's why I dropped that part. But yeah, CML can be used to compare, to evaluate, and compare different codes or different branches, different models or different codes or different hyperparameters now in the PR itself.
So we've got a question coming in here from Jules asking about, for the test data, do you update this over time? E.g., how is it performing on new records rather than those pulled from distribution of the training set?
Yes, it's a very good question. Whether we update the test data set and all, ideally, it depends on the challenge. Let's say you are working, if it's a Kaggle challenge and all, there's no update of the test data set, right? You have a fixed data set, or you make a proportion of it, or you make a division of it and say that this is my sole test data, and you want to run experiments only on top of it. But in real scenario, it's never the case that your data keeps on changing. How you update the data set is going to data, like how MLOps is a difficult pipeline to manage. Similarly, data pipeline, what data to consider, how data is updating, or what data features to consider, what test data, or what proportions to use, it keeps on changing. So how data is the data accurate enough? How are you doing data labeling, data management? So that itself is a different topic itself in itself. Coming to the major point, that whether you update a data set or not, ideally we should. But whenever we update a data set, so the comparison should be fair, that since you update a data set, the comparison probably on the old models you might have done on a different test data set, and the new model you might be doing on a different test data set. So it's not an apples to apples comparison when the metrics are compared. So if you're updating it, make sure that whenever you're doing a comparison, you make sure that you refer to a common test data set, which can be tracked also. That this instance of test data set is what you have used to build this particular model.
The whole data pipeline and data ops part is for another day, and we'll have you come back on to talk to us about that. There's another question coming through here from Simon. How do you consider, I guess it would be, have you considered serverless inference using AWS Lambda versus containers for inference service?
Containers is, as I said, so AWS Lambda is also works on top of containers. Okay, it's actually, there are different ways to trigger a particular Lambda, or you can compute that. Either you can actually write the code in the AWS Lambda itself and say that you run this particular code, or you can say that this is my Docker image, and in the Docker image you specify that this is the handler or this is the particular function you want to execute. So in that way, you can make that as a containerizable application also for AWS Lambda. As I said, why I preferred AWS Lambda over normal EC2 or ECS or EKS is that, not EKS, EC2 and ECS is that it is very easy to scale the application. I don't have to worry about the amount of instances I have to maintain. Let's say if it is a EC2, right? I have to first create a EC2 instance, then go and make sure that all the Docker dependencies were there and all. Then I say that this is the Docker image you have to fetch from and all, and then create an instance, and it has to keep on running, right, in order to able to get a particular request. Whereas AWS Lambda is, if you could do a cost comparison also, if there is no request coming up, it will automatically sleep, so it will automatically die. And whenever a request comes, it might take some time to spin it up, but yeah, so that's how you can have there is as I said, there is always a trade-off between each mode of deployment you choose. In the case of live inferencing, where you want a immediate thing and all, if the Lambda is not warm, which means that it's not up yet, then to make the Lambda warm, it depends on Docker images. If you're downloading directly from S3, you are downloading a model and all, it might take a couple of seconds to spin that AWS Lambda and then get that prediction or the request served and all, which is probably a very cost application or not the use case you're looking for. In that scenario, you might have to go for EKS or on EC2 kind of deployment, where there is always a server running irrespective of whether a request comes or not. Depends on the use case, I would say. But the use case I am looking for is that it should be able to scale up. Depends on if there are too many requests, it should be able to scale up automatically. I am not worried about for the initial request. There are different ways to trigger. I can have a CloudWatch trigger or not, whatnot, to trigger automatically AWS Lambda every minute and all to make sure it is warm. There are many cost constraints also here, or compute constraints also. For example, that with AWS Lambda, you don't have a GPU instances spawning. You can only spawn CPU-based instances. Whereas with an EC2 and all, you can have a GPU-based instances also. Depends on if your model requires a GPU thing, then AWS Lambda is not the way to go as the thing stands right now. Then EC2 is the better way to go with it. So it depends. I mean, you have to point out, okay, this is what exactly you want to require. Then based on that, I would say choose the architecture wisely. It's not AWS Lambda is always the best.
Yeah, as David Aponte says a lot in the conversations that I have with him, he's always pounding it in my head. Be aware of the SLOs and the SLAs you have and how there's no wrong decision. It's just trade-offs. You have to look at what your use case is. So last question, I guess, and then we can let you get rolling again. Did you find that using AWS Lambda rather than ECT EC2 AKS saves money in the end?
I would say comparatively at my organization, we prefer AWS Lambda is saving more money compared to EC2. EKS, we haven't yet tried because there is a learning curve involved there. You have to learn about a bit of Kubernetes on how to debug or how to configure all those things. Compared to the AWS Lambda, you don't have to worry about all those things since it will configure for you and all. A minimal configuration compared to EKS. I can't comment on EKS, how much cost it is saving, but yeah, it's comparatively saving more cost compared to EC2. Yeah, it is saving. Lambda is saving for us.
Awesome.
Depends on how many models you are having also. So currently we are maintaining 1 to 2 models only. So that's why it is very easy for us. And we don't have to worry about immediate responses right now. We will be getting a batch of responses and we might get thousands of requests at a single go, where then AWS Lambda is where it will auto scale for us. Whereas EC2 is not able to do that.
Excellent. All right, man, we'll let you keep cruising for the next part of your presentation.
Yeah. So now that we have deployed the model up and running, we are able to get the predictions from it. What next? Is ideally, I would say not everyone, but majority of the people stops at that point that, okay, model is now done. Getting predictions or getting value from that, it's done. It's not. So there are, this is where the major problem comes up, which is the monitoring systems. Like monitoring systems can help us giving confidence that our systems are running smoothly. And in the event of a system failure and all, can quickly provide appropriate context when diagnosing the root cause. So the things we want to monitor during a training and inference are different. During training, we are concerned about whether the loss is decreasing or not, or whether the model is overfitting, etc. or not. But during inference, we would like to have confidence that our models is making correct predictions. What things can go wrong in the case once you deploy a model? is that the underlying data distribution has shifted over time and the model has gone stale. That is, the inference data characteristics is different from the data characteristics used to train the model, which is a very common use case if you are, for a particular client or for a particular data set. It's not that every time you are getting the same text, the dynamics of the text will keep on changing over time. That's the one major concern. The second is that the inference data stream contains edge cases not seen during the model training. In scenarios, model might not perform poorly or can lead to errors. That at a time, during training, you might have only 10 classes, but over a particular 1 or 2 months down the line, there might be a new class added to your problem statement, and the model might not know that. That's one of the data drift can happen. Now, the other thing is that model can be, this is a common configuration problem, that model can be misconfigured. You might have changed a different model, or you might have a misconfigured to a different configuration or whatnot. Now, in all of these scenarios, the model still makes successful predictions from a service perspective, because it is able to load the model, it is able to make a prediction, and you are getting the result from that. But the predictions will not likely be useful because of the changes and all. We have all seen that. Monitoring machine learning models can help us detect such scenarios and intervene. That is, example, trigger a model retraining or deployment pipeline. You can have many of the alerts configured that there is a drop, you're not getting predictions, or a particular label is getting predicted every time, or the confidence of the predictions is very less, then you can have an alert triggered for that. So all this monitoring will help us understanding whether we are making the predictions in production correct or not. So we have to make sure that once the model is deployed, all these concerns are valid, or all these concerns are addressed. Now, how can we do that? Is I preferred a Kibana thing, where what I'm trying to do here is that you have a Lambda, and whenever you receive a request and all, you write all the corresponding logs, whether it's a request or what the model you are using, or what logging, or what is the time you take for a particular request, what is the input data, and what is the predictions you are making, all that stuff to a CloudWatch logs, whether it is a success message or error message, whatnot, to CloudWatch logs. Then you can stream these logs to a particular service, which is Elastic Cluster Service, and then use Kibana to beautifully visualize all that particular logs. Then you can have a trigger or timeline that you refresh it for every 5 seconds, or delete it after every 2 weeks or whatnot. So all these things can be configurable. Now you can have a single dashboard that you can see what are the different requests you are getting, or what are the different kind of inputs you are getting, or how many labels you are predicting over a particular point of time, how many errors you are getting, what are the logs you are getting. All these things can be visualized via dashboard, and you can have your own visualizations for your own charts. You might have different problem statements here. You can have different dashboard for each of the problem statement there, and you can have a consolidated list, whatnot. So all these things can be configurable here. I have described, as I said, in the blog post on how to configure all these things. Yeah, you guys can take a look post the session. Now how does the summary looks like is that, so this is what the pipeline, the end-to-end pipeline gonna look like, that you have initial model, you have the model training and all, and you monitor it, you monitor it via using weights and bias, and you fetch all the configurations or configure all that via Hydra. Then you have a trained model, you convert that to a single file format, which is the ONNX, and then you store that model via in a remote storage via a DVC thing. Then you package that code, all the code used for training or inference, via Docker image, and then you have a triggers setup, that CI/CD triggers setup. Whenever a changes happen, you automatically do all these steps and all, and then create an image, and you store that image in a ECR thing. Whenever a trigger happens, that let's assume that one possible trigger is that whenever you merge to a master, then fetch the latest image from ECR and deploy that model to a production. So you take that trigger, based on the triggers and all, you spawn a Lambda with the corresponding updated ECR image, and then there is an API gateway which configure what is the endpoints you want to have to access this particular Lambda. And whenever a request comes and all, you write that particular logs to CloudWatch logs, and then you stream it via Elastic Cluster to Kibana dashboard, and the admin or the product concerned can monitor the dashboard and see what's happening about the particular model deploy. So what could be the next step? So these, as I said, this is not a comprehensive guideline. So this is just a basic of end-to-end. I know there are many tools because MLOps is hard. It's not a very easy thing. Many tools are coming up nowadays that which are excelling at one particular part, not a single thing which can do all the things. The hard part is to make the things look simple, to make the job easier. I think the research or the work has been keeping effort on that. People are trying to make things automated or make things even easier. We need to work more on that. So this is only basics, but things looks very complex, or things can go complex on the production scenario and all. So what things can be done even better, or what are the next steps, or how we can improve the existing systems is that different ways of updating a model. That currently there is not proper checks. You might have to do we are currently in the existing pipeline. I just do on a validation on a particular test set and then updated it, but it's not necessarily the case. You might have different models or different kinds of deployment, which is a blue, green, canary or A/B testing kind of things, and different ways of serving the model. Currently, since it's a one or couple of models, we are leveraging the AWS Lambda directly itself. So, but if you have some hundred or thousands of models and you want to different versions of each of the use cases and number of use cases were there, how do you want to trigger or how do you want to manage that? So then you have a particular like frameworks you have which can support all this stuff, which is TOSF, KF serving, or Seldom core and all. Different things to monitor. Currently, as a part of basics, I just covered only the logs or error logs thing. But as discussed, the data can be different. The concept can be different. You can have stats around your training data that you are expecting a distribution of a particular label to be this percent in the training. But in inference, if you have a different distribution, you can have that as a concept or a data drift there. Then you can compute, have an alert that during inference, this particular label is seeing more than often when you expected in the training part. So you can have different kind of alerts or different things to monitor, whether it's a time or response taking and all, or the error rates and all, or continuous evaluation as you keep on updating the test data set. You might want to deploy your model and keep on evaluating that on the corresponding test data set also. Automated cloud configuration. I mean, it's hard to go through Lambda and configure all these things and all. So there are cool tools like infrastructure as a service tools. It's supposed to be in infrastructure as a configuration tools that it is a SAM, Terraform, serverless framework and all, which helps us configuring all these things in a single file, which could be an YAML file and all, where you can provide all that services you want, and it will automatically spin up that corresponding infrastructure for you. Which makes that you don't have to go to different tools and all. You just have a single file and it does a job for you. And data orchestration, as discussed in the starting, that handling data is a difficult thing, and you might want to configure different pipelines for each of the data processing things. You might have to have different 10 number of steps or different DAG things and all. So all these things can be configured via different tools called DAG Prefect, Metaflow, Airflow. All these things are example of tools which can be used for orchestrating pipelines. Now testing of the code. So proper testing of the code, like using PyTest and all, make sure that you are following the proper typing standards, or the normal test cases are loading them properly. If you want to have a robust test cases like test attack, where you purposefully probe the input in a way that your model, make sure that model is robust and all, you can have any kind of testing involved. So all these steps are not covered as a part of basic pipeline, but you can there's a couple of steps which you can improve on the existing things. You can have a complete code or all the blocks. So I can give a glimpse of it. So you can have, I made that into 10 weeks. So you can have all these things. You can randomly go through a particular thing called DVC, and you can see all the configurations, all the code explaining and all, everything is done there. And the GitHub repository contains all that, all the vCli's division of it, and what I'm covering in that, and the corresponding blog post links also here. So that's it. Any Q&As?
First of all, that's so awesome, dude. I really appreciate the amount of time and effort that you put into this learning journey. So Thank you for that. There are a few questions coming through. One is about the slides, if you can provide them for us. I know that you'll give them to me. I'll put them in the newsletter. If you're all subscribed to that, I'll throw them in the weekly newsletter.
Sure, I can try, not a problem.
But yeah, and then the other question that we got was coming through. Have you considered Amazon SageMaker as an option?
Yeah, that it needs to be explored. The SageMaker, I haven't yet explored on top of that, but on a like nutshell, or it looks like it is automating majority of the stuff. I don't have to interact with many tools, but the cost is also a matter there. It is way more expensive compared to Lambda and all. If I'm not wrong, some 3 to 4x times it is costed. So as I said, there is a trade-off for every tool we choose, but yeah, I haven't yet explored on it.
That's so true. You do pay a premium for SageMaker, that's for sure. There is a question that I like to ask people when they show me their architecture and like how you've done it, and that is, how do you manage dependencies throughout all of these different tools that you're using?
Yes, that's where we have the code dependency, right? So we have the Docker for that, which helps. You can have different Docker files for different environments and whatnot, or for training you might have extra dependencies, or for which where you want to do more testing or whatnot, and for inference you might want to have a different Docker file. So for now, I would see the easiest step would be having a Docker file which has that all dependencies maintained there.
Excellent. And there's another question coming through. How do you quickly differentiate a new tool in the market, a tool that solves the same product but in a different, or a tool that solves the same problem but in a different way as to optimize efficiency, or it takes a different approach?
Yeah, choosing a tool is always a difficult choice to make. So a couple of things I would evaluate is that first thing is what is that learning curve? How easy or how difficult it is to learn that particular tool. Depends on that. I would choose that. The second thing is how cost effective it is. Not everything is free. You have to pay a price for most of the tools we are using. So how costly it is, and how much it is automating the job for us. Like if it is exactly the same problem which other tool is doing, but it's relatively cost, I won't go for that. But it is offering more things, like as an example, SageMaker, right? It is probably offering more tools for notebooks automation or whatnot, a logging thing and all. It's probably have a easier integration with Kibana and whatnot. Then it has more pros. Then the con would be the cost, like how much I have to pay for that. If its price is not a concern, then I would go for which solves majority of the single tool. If a single tool solves majority of the problem, but cost is not a concern, then I would go for that. If not, then yeah, I would say I have to evaluate. But it's a difficult choice to make which tool. And every month or so, there is a new tool coming up which is solving a different problem or a particular problem in a different way. So it's difficult to choose. It takes time to get an expertise or get a rough understanding, or you have to define your own like problem statements. If that solves, then you should go for that.
Yeah, that's super interesting too, because it's also like, what tool, if you need to integrate a new tool into your stack, what is going to give you the most benefit, right? Yeah. Like, what's going to be the low-hanging fruit there? And one thing that you said that I rarely think about, but it is so true, is how difficult is it going to be for me to learn this tool? What is the learning curve there? That is huge. That you just opened a door in my mind, because it takes time and resources, and you're not going to be able to do very impacting things if you are trying to learn the tool. So yes. There's another question coming through here. Do you see a single provider, apart from AWS, GCP, Azure, providing an end-to-end solution? There are a few out there. I know that like Iguazio has one. I know DataRobot also has one. Have you looked into any of those?
Not yet. As I said, there are many tools to explore. Rather than exploring all the things, my personal choice would be, okay, if this solves my problem, let me not worry about all the tools coming up, because there is a Selden core, there are TF serving, which serves the model in a better way and all, but I might not need it, right? I just have one model to serve. Why do I have to worry about all the things it is providing, which I don't require? But yeah, I mean, there are many tools there are many tools out there. As I said, it's a difficult choice to make whether to go a single tool which provides all that or not. Depends on all the, as I said, prior discussion, cost, learning curve, how things are easy to configure, everything. So everything plays a role in choosing a tool.
Raviraj, this has been an amazing session. And really, if you have not checked out Ravi's GitHub and blog post on this whole learning journey, go check it out. It is super informative. I am so appreciative of what you have created for the rest of us. It's so cool to see. And thank you so much for this session. This was awesome, man. Really appreciate it.
For me having me over. You can find all the resources. I'll provide all the links anyway. MLOps community, you can share that. Or you can have a summary blog where I provided most of the resources I followed. There are many resources out there coming up, but yeah, do follow. It's an interesting topic to learn.
I look forward to the next blog and what you evolve on top of this stack, because this was the basics, right? What is the intermediate and then what's the advanced going to be? I really appreciate the effort that you put into it. And so where are you going next? Do you know?
As I said, in the next steps, I also want to learn. I also don't have the expertise in that yet. So I'm also looking towards a better way of serving the models, a better way of configuring the things so that it makes my job easier. Trying to crunch, is there a single tool and all, so that I don't have to switch between different tools, and making sure, I want to scale the things via pipelines so that all this infrastructure management can also be done easier. Yeah, I want to improve the existing things, different kinds of deployment and all. Yeah, these are, as I said, these are the 6-7 points I want to improve on.
And do you see it as being another like learning journey where you're going to do like 10 weeks?
Definitely, it's a learning journey. I think it would take 3 to 4 months at least, if not more. At the very least, it will take 3 to 4 months to cover each and every topic there.
Nice. Well, I look forward to it, and we'll have you back on once you set that next learning journey for the rest of us.
Yeah, sure.
All right. See you later, man.
Yeah. Thanks, everyone.
Thank you, everybody. We'll see you all